Hello students, I am Swami K, Assistant Professor of Mathematics. Today I would like to start Laplace Transforms, which plays an important role in science and engineering. Laplace Transforms can be used to solve the differential equations and is mainly used in mechanical engineering and electrical engineering. Laplace Transform converts a time domain function into a function of frequency. Let us see the definition of Laplace Transforms. See the definition. Let f of t be a function which is defined for all t greater than or equal to 0. Okay. Then the Laplace transform of f of t denoted by L of f of t is equal to integral 0 to infinity e power minus st into f of t dt, provided this integral exists. Okay. Now, since the result is a function of s, say this is f bar of s. Here s is a parameter that may be real or complex. Okay. S is a parameter which may be real or complex. Right? The Laplace transform of f of t is equal to f bar s. That means Laplace transform converts. Suppose f of t is time domain function, Laplace operator converts time domain function into a function of frequency. Okay. We have linear property in Laplace transforms. Linear property. Okay, it is L of a into f of t plus b into g of t, where f of t and g of t are two functions of t and their arbitrary constants, is equal to a into L of f of t plus b into L of g of t, where a comma b are constants. Okay. This is linear property in Laplace transforms. Now let us see the Laplace transforms of some standard functions. First one, L of 1 is equal to 1 by s, where s greater than 0. L of 1 is 1 by s. We can easily prove this by definition. L of 1 is integral 0 to infinity e power minus st into f of t. In place of f of t, write 1. Okay. Now the integration is e power minus st by minus s between the limits 0 to infinity. That is equal to minus 1 by s into the upper limit is infinity. This becomes e power minus infinity, that is 0. Minus the lower limit is 0. If you substitute 0, e power 0, that is 1. Okay, is equal to 1 by s. Since e power minus infinity is 0. Okay, this is L of 1 by s. Next, L of second one. L of e power at is equal to 1 by s minus a, where s greater than a. L of e to the power of at is 1 by s minus a. Okay. By definition, L of e power at, the Laplace transform of f of t is integral 0 to infinity e power minus st into f of t, where f of t is e power at dt. That is equal to integral 0 to infinity e power minus of s minus a into t dt. Okay. Now the integration is e power minus of s minus a into t all by minus of s minus a between the limits 0 to infinity. That is equal to minus 1 by s minus a into, now if you substitute infinity, this becomes e power minus infinity. E power minus infinity is 0, the lower limit is 0, e power 0 is 1, that is equal to 1 by s minus a. L of e power at 1 by s minus a. Similarly, L of e power minus at is 1 by s plus a, where s greater than minus a, right? Next one. L of t power n is equal to gamma n plus 1 by s power n plus 1, where n not equal to minus 1. To know this, first you have to know about gamma function. Gamma function. For any constant n, gamma, we define gamma n integral 0 to infinity e power minus x, x power n minus 1 dx. Okay, this is gamma function. We have some properties of gamma function. Gamma of 1 equal to 1 and gamma of n plus 1 is equal to n into gamma n. Gamma n plus 1 is equal to n factorial if n is non-negative integer. If n is a non-negative integer. And also gamma 1 by 2 is equal to root 5. Okay. These are some properties of gamma function. Okay. Here L of t power n is gamma n plus 1 by s power n plus 1. We can easily prove this now. So by definition, L of t power n, by the definition of Laplace transform, L of t power n is integral 0 to infinity e power minus st into t power n dt. Put st equal to x. St equal to x. Then dt is equal to dx by s. Now substituting in 1, see that L of t power n is equal to, here t limits are 0 to infinity. When t is 0, x is 0. When t is infinity, x is infinity. X limits are also 0 to infinity, e power minus x. Here t is x by s whole power n and dt is dx by s. That is equal to 1 by s power n plus 1 integral 0 to infinity e power minus x, x power n dx. Understand? That is equal to 1 by s power n plus 1 integral 0 to infinity e power minus x, x power n plus 1 minus 1 dx. Now by the definition of gamma function, this is gamma n plus 1. Okay, gamma n plus 1 by s power n plus 1. Okay, L of t power n is equal to gamma n plus 1 by s power n plus 1. And if already know that if n is a non-negative integer, then gamma n plus 1 is n factorial. Okay, therefore L of t power n is equal, if n is a non-negative integer, gamma n plus 1 is n factorial by s power n plus 1, where n is a non-negative integer. Okay, L L of sin at is equal to a by s square plus a square. S greater than 0. You can easily prove this by definition. L of sin at is integral 0 to infinity e power minus st into f of t. Here f of t is sin at. Now we have a formula here. Integral e power ax sin bx dx is equal to e power ax by a square plus b square into a sin bx minus b cos bx. Okay. Using this formula, this can be written as e power minus st by minus s whole square, that means s square plus a square into minus s sin at minus a cos at under the limits 0 to infinity, right? Here the upper limit is infinity. If you substitute infinity, the first term becomes 0, since e power minus infinity is 0. Minus e power 0 is 1 by s square plus a square into sin 0 is 0 minus cos 0 is 1, a remains here. This is equal to a by s square plus a square. Okay. L of sin at is a by s square plus a square. Okay. Similarly, you can prove L of cos at is equal to s by s square plus a square, right? L of sin at is a by s square plus a square. L of cos at is s by s square plus a square. Go to the next one. L of sin h at, hyperbolic function. L of sin h at is a by s square minus a square. The proof is very easy. L of sin h at. What is sin h at? L of e power at minus e power minus at all by 2. Okay, by the linear property, this can be written as half into L of e power at minus L of e power minus at, right? L of e power at is 1 by s minus a minus L of e power minus at 1 by s plus a. Okay. This is for s greater than a and this is for s greater than minus a. That equal to 1 by 2 into s minus s cancel, 2a by s minus a into s plus a for s greater than mod a. Since both s greater than a and s greater than minus a, that equal to a by s square minus a square for s greater than mod a. L of sin h at is a by s square minus a square for s greater than mod a. Similarly, L of cos h at is equal to s by s square minus a square. Okay. These are the Laplace transforms of some elementary functions. Let us see the formulas once. F of t, L of f of t, that is f bar s. Okay. L of 1 is 1 by s. L of t power n is gamma n plus 1 by s power n plus 1. Okay. Or if n is non-negative integer, n factorial by s power n plus 1 if n is a non-negative integer. Okay. L of e power at is 1 by s minus a e power minus at 1 by s plus a sin at a by s square plus a square cos at Laplace transform s by s square plus a square sin h at Laplace transform is a by s square minus a square cos h at Laplace transform is s by s square minus a square. Okay. Remember these formulas. Okay. So now go for the problems. Evaluate L of e power 2t plus 4t cube minus 2 sin 3t plus 3 cos 3t. L of e power 2t plus 4t cube minus 2 sin 3t plus 3 cos 3t. By the linear property, it is equal to L of e power 2t plus 4 into L of t cube minus 2 into L of sin 3t plus 3 into L of cos 3t. Okay, is equal to L of e power 2t is 1 by s minus 2 plus 4 into L of t cube is 3 factorial by s power 4. Since L of t power n is n factorial by s power n plus 1. Okay. Minus 2 into L of sin 3t is 3 by s square plus 3 square, that is 9, plus 3 into cos 3t Laplace transform s by s square plus 9 is equal to 1 by s minus 2 plus 4 into 3 factorial is 6, 24 by s power 4 minus 3s minus 6 whole by s square plus 9. Or this can also be written as 3 into s minus 2 by s square plus 9. Okay, this is required Laplace transform. And see the first one, L of 2 power t is equal to L of 2 power t can be written as e power log 2 power t, that equal to e power L of e power at, where a is log 2. L of e power at is 1 by s minus a. This is 1 by s minus log 2. Since L of e power at is equal to 1 by s minus a, right? See the next one, L of t square plus 2t plus 3 is equal to L of t square plus 2 into L of t plus L of 3. The L of t square is 2 factorial by s cube plus 2 into L of t is 1 by s square plus L of 3 is 3 by s. Okay, is equal to 2 by s cube plus 2 by s square plus 3 by s, right? Okay, thank you so much for watching.